In this lesson, we are going to explore some interesting and unusual reactions of group 7 of the periodic table, the halogens. Let's start with a chlorine reaction. Now you have heard about the reaction of hydrochloric acid with sodium hydroxide, but what if you were to bubble diatomic chlorine gas in some cold sodium hydroxide solution? The reaction is not the same. As well as sodium chloride salt and water, we also get sodium hypochlorite made up of a normal sodium plus ion, sodium 1 plus cation, and the hypochlorite 1 minus anion seen here. This reaction is very popular in industry because the resulting mixture of the three products work perfectly as a bleach, and once it has been diluted to a 3 to 8% aqueous solution, that's exactly what it sold us: household bleach, the cleaning stain removal from fabrics and sterilizing. Here's something you might not have considered before. Different halogens can react with each other. Chlorine and iodine can react together to form iodine monochloride. Here is the thinning, though iodine monochloride is a brown liquid and vapor which looks very similar to diatomic bromine. Not only that, their molar masses are almost identical. So how could we tell whether we have iodine monochloride or bromine in our test tube? We can drop in a strip of tin metal with iodine monochloride. The more reactive chlorine forms the liquid tin tetrachloride, while the displaced ionic atoms pair up to become diatomic purple iodine vapor. In contrast with bromine, the test tube will become colorless as all the bromine reacts with the tin to form the colorless liquid tin bromide. Now, a reaction involving fluorine. Have you ever heard of hydrofluoric acid? You will probably never have seen any in your labs because it is so dangerous it cannot be stored in glass bottles like other acids are. Hydrofluoric acid is so corrosive that it can attack in dissolved glass. He does this by forcing the silicon dioxide components of the glass, which is usually chemically inert, to react, forming silicon tetrafluoride and water. It is the only acid capable of doing this. Here is a challenge: if you start with hydrogen gas, fluorine gas, and silicon dioxide, can you write a balanced equation showing how the process happens? You will need two different chemical reactions. Pause the video and have a go, then resume. Is the answer? First reaction is this: because of the reactivity of fluorine, the reaction has to be carried out in the dark and a low temperature. Otherwise, U is causing an explosion. And here is the second reaction: hydrofluoric acid can only be stored in certain types of plastic which are resistant to its corrosive power, but we can exploit this power. To hydrofluoric acid is used industrially to create patterns on glass, a technique called etching. Finally, you may know that iodine can be used to test for the presence of starch, but what's the chemistry behind this? Starch is a very large polymer of sugar molecules, a polysaccharide. It is how plants store their glucose before they respire it to provide their energy. In an aqueous environment, one of its component, amylose, forms long repeating chains which are coiled rather like tiny springs. We can make an iodine-based reagent by dissolving diatomic iodine in an aqueous solution of potassium iodide. This creates the negatively charged triiodine ion. Now, it is just so happens that these triiodine ions are the perfect size to fit the middle of the starch spring. So in they go, and the chemical interaction between the triiodine and the starch causes very intense dark blue-black color. You will see if you add a drop of iodine to a potato or piece of bread. We use this reaction to detect fake banknotes by using detector pens with an iodine-containing ink. The paper used to print official banknote is starch-free, but most common types of paper contain starch and the coats not blue.